Hello once again, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek into my personal experiences. This is a channel designed with you in mind. Let us dive into today's lesson. As we continue with the ultimate guide in mathematics, and we are continuing with our number patterns, sequences, and series. In this section, on the last part of the series, we are looking at the sum to infinity. So we have looked at the arithmetic series, geometric series. If you haven't looked through this, go to the previous videos and you'll be able to gain a good understanding of those. So now let us look at the sum to infinity of a geometric series. So now when we talk about the sum to infinity, and we use this sign is for infinity, so that's the sign for infinity, is equal to a over 1 minus r. So this is the formula that you use when you talk about sum to infinity. But there is something that I want to bring to you, because you need to understand the condition that this particular formula works, and this is the condition you must always state. It's minus 1 is less than r is less than 1. By r we mean what? The common ratio. So don't forget, this is the condition so that this can hold true. And this type of condition, we say there are two types of sum to infinity. There is a convergent series. So this is the condition for a convergent series where the common ratio is between -1 and 1. And then there is a divergent one, divergent series. So if they ask you to say, does this series converge, you must make sure that you prove that the common ratio is between -1 and 1. I'll just show you that. But if it's divergent, the common ratio will be either r will be less than -1 or r will be greater than 1. So that is where you will discover that that particular series is divergent. Now let us make an example of what we're talking about here. It says calculate the sum to infinity of the following geometric series, and then they give you that. Now don't forget, this is my I'm just going to work it from here. This is your T1, your T2, and your T3. So now the first thing that you need to do is to find what? Calculate the common ratio. So r is T2 over T1, which is equal to what? Because already they told us this is a geometric one. So which is what? Which is 2 over 3 and then divided by 2. Be careful how you write this and how you punch this in your calculator. Okay, you can even use the other one to say which is equal to is T3 over T2. If it's T3 over T2, it was going to be 2 over 9 then over 2 over 3. I think that you can use one of these. It will give you the common ratio for that. And then if you calculate then r, it will be, you see, I've got the fraction, but on top I've got another fraction, which is 2 over 3 and then divided by 2. What's the common ratio? Is 1 over 3. Let's try the other one. There is a fraction on top, which is 2 over 9, and then go down, there is another fraction, which is 2 over 3. You just have to check to say, okay, I'm getting 1 over 3. So you'll be knowing you didn't make errors. So you can see that my r is equal to 1 over 3, and then my a, which is the first term, is equal to that one, T1, which is equal to 2. Now look at the condition I said. We said for it to be a convergent sum to infinity, it has to be in the range of -1 is less than r is less than 1. Just check if it does fulfill that, which is correct, because you can see that it lies somewhere, 1 over 3 lies somewhere here. If I put it on a number scale, this will be like this. I have got in here minus 1, and I've got 1. So r must be between this range. Are you with me? So that is the range of r. So look at this. If I say this is 0, and where is 1 over 3? 1 over 3 lies somewhere, let's say somewhere here. You've got 1 over 3. Do you see that it does fulfill that part? So in a way, you're going to have r that is a fraction or a decimal, 0 comma something. So your r must be 0 comma, not above 1, positive or negative. So it must be a fraction in a way, or it must be 0 comma, for example 0 comma whatever number you have. It can be negative or positive, it doesn't matter, but you cannot have anything above 1 or above or below negative 1. If it's like that, then it becomes divergent. And then from there, you can now write the formula for sum to infinity. What is it? Sum to infinity is equal to a over 1 minus r. And then we continue. Sum to infinity is a, which is 2 over 1 minus 1 over 3. So where is it going to converge? That is the part. And then use a calculator there, which is 2 over 1 minus a third. And then you get 3. So this will converge at what? At 3. So that is the first part. Now let's try another one. Let's try another one and see if we can do more examples. It says the first term of a geometric series is 124. The sum to infinity is 64. Find the common ratio. So these are quite common questions that you can get in an exam. It says the first term of a geometric series is 24. What do they mean? They mean a is equal to 124. That's the first term. And then they're saying again the sum to infinity is 64. And then you've got s to infinity, which is called what? 64. And then the question says what? R. Find the common ratio. That's what we're looking at. Then R is what we're trying to find there. And then what we do from here, you are given the formula for the sum to infinity. The moment they say sum to infinity, write that formula. Sum to infinity is equal to a over 1 minus r. Are you with me? Then we know the sum to infinity. They told us it what? It's 64. Then you say 64 is equal to, what is my a, which is 124 over 1 minus r. You see that? Then at this stage is for you to solve. This is over 1. Then what you do, you cross multiply. Now look at this. When you cross multiply, when you're cross multiplying, it's 64 times this. It's 64 times 1 minus r is equal to 124. If you just do it like that, you're gonna get it wrong. Whenever you've got 1 minus r, 2 items, you have to protect that with a bracket, so that 64 will, you open it, it will affect that, and 64 will affect that. That is another way of doing it. All right. Or instead of opening the bracket, you are allowed to divide instead by 64. But since I've already opened the bracket, you could have divided by 64 over 64 once. It was going to be even fine. But now, since I'm already opening the bracket, it's still fine. 64 times 1, it's 64 minus 64 times r. 64r is equal to 124. And then after that, it's up to you. I can take 64 to join that, which is negative 64r is equal to 124 minus 64. All right, which is negative 64r. And then when I simplify that, which is 124 minus 64, it gives me 60. Then what do? I divide by negative 64 on both sides, just to get what? My r. The question is, what is r? Then r is equal to, if I can then apply my calculator there to say 60 over negative 64, then it gives me 15 over 16. You can press that, which is 0 comma to 2 decimal places 94. Alright, negative 0.94, or you can leave it like us to say negative 15 over 16. Negative 15 over 16. Then that becomes the common ratio. Are you with me? So that's how you can solve some of these questions when they come asking for that. Let's say this is that. So let's put it aside there. Alright, now look at the next one. It says show that 0.9999 is equal to 1. These are common questions that they can bring. It also involves what? It's sum to infinity. So they are saying here I need to show that what? 0.9999 is equal to 1. Remember, when you're rounding off, this is actually equal to 9. But what can you do? You can use your sum to infinity. For example, what is 0.99? It is 0.9, right? Look at this. I can write it like this. I think this will make sense to you. If I can say 0.9 plus 0.09 plus 0.009 plus 0.0009. How many are these? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. You see this? So I can write it now straight away to say this is same as 0.9, because when I'm adding this all together, it will give me 0.999. You see that? But I'm going to be writing this down, which is 0.9 plus 0.09 plus 0.009 plus 0.0009. Are you with me? Now let's say I want to take it, I think it will be fine from here. Let's say I want to take it from here, and I say this is my T1, this is my T2, this is my T3. And as you can see, this was continuing. If this is my T1, T2, T3, and I say to that, what is my R? Remember, common ratio is T2 over T1, which is what? 0.009 over 0.09, right? Which is equal to what? Let me find the one common ratio first. So it will be 0.009 over 0.09. It will give me 1 over 10. You can try T3 also, over T2, 0.1239 over 0.129. You see, it gives you 1 over 10. So now if we can say sum to infinity here, sum to infinity is equal to A over 1 minus R. Now our A is our T1 there, which is what? 0.09 over 1 minus 1 over 10. Right, let's see what we get in that part, which is 0.09 over 1 minus 1 over 10 equal to, the answer is what? It's 1 over 10. Now if you press ST, which is 0.1, the answer here is 0.1. Now when then continue to say, so which means that simplifies to 0.1, you can therefore say this is equal to, I'm just gonna work it back. Remember, we said here this became 0.1, but we said plus this 0.9. You see, so 0.1 plus 0.9 is equal to 1. You see that it's 1.0. That's why they said show that this is equal to 1. So you add 0.9, this reduces to what? This reduces to 0.1 using the sum to infinity. So we are saying 0.9 plus 0.1. If you add 9 plus 1 is 10. 0 carry 1. 0 plus 0, 0 plus 1. This is 1.0. Alright, that's one way of doing that. Let's look at the other question, whereby it's also similar to say convert the following, convert each of the following recurring decimals each of the following recurring decimals to a common fraction. Okay, I've got 4,2 recurring. Remember this part when they say 4,2 and 2 recurring, what does it mean? It's 4,2, 2, 2, 2, 2, 2, and so on. Now, how can you write it? Similar to what we did there. You say 4, right, plus, you see that, 0, 2, and then if I can write it down for you, you will see it better. If I say 4, before I do this, let me say 4 plus 0, 2 plus 0, 02 plus 0, 002. You see what I'm doing? 0, 0002. You see that? So that's what you'll be having. So even here, you'll be having 4,2 recurring is equal to 4 plus 0, 2 plus 0, 02 plus 0, 002. You continue like that. I see that. Then, which is 4 plus, then take this, and you can see that it's continuous. It's continuous, which means it's sum to infinity. Then what you do, you come back and say, all right, I've got that part. Let me find my R. What's the common ratio there? R is T2 over T1. Then R is what? Now this is T1, this is T2, which is 0, 02 over 0, 2. Then you find your what? You find the common ratio there over 0, 2. Am I right? Then it becomes 1 over 10, which is equal to, you can leave it like that. Let's leave it like that, but it's 0, 1. Then you find sum to infinity, which is S to infinity, which is A over 1 minus R, which is A, which is 0, 2 over 1 minus R is 1 over 10. Then you can find the sum to infinity at that stage. It becomes 0, 2 over 1 minus 1 over 10 equal to, then you've got 2 over 9 ST, which is equal to what? It simplifies there. Let me look at this. It's actually there is fine. It says it's 2 over 9. It's 2 over 9, which is equal to 2 over 9. You saw it was 0,22. The question was convert each of the following recurring decimal as a common fraction. Now I see. So now what you have, you've got that plus 2 over 9. See that? Which is equal to 4 and 2 over 9. I see that. That's what you're having. Now, if you are to do and say 4 plus 2 over 9 is 38 over that, but shift, remember it's 2 over 9. Are you with me? If you press SD, it's 4,22222. Are you seeing that? But you're using what? You're using sum to infinity for that. So guys, that's how you work about on the sum to infinity. It is gonna end up here, but in the coming lessons I'll be now doing previous question papers that are covering this section of series, whether it's arithmetic, it's geometric, as well as some sequences. I bring you those questions that you expect now in your exam. So that is the next part. It will be exam revision. Now I'm going to be preparing you for your final exam, even for your term 1 test. You'll be writing your June, your prelims. This will always come handy. Now, what is the next topic from here? The next topic from here, just getting ahead of myself, is trig. You definitely need to check out on the next part that I'm bringing here is trigonometry. Then after that, I'll bring you functions. So I just want to bring you trigonometry, and the trigonometry is continuing from grade 11, where I'll be looking at the compound angle formula as well as the double angle formula, and then some nice questions that can take you into the exam. You definitely need to know how to derive these. So join me in the next lessons that will be coming. Stay tuned on the 24-minute lesson. you need to be subscribed so that you can always follow up on this. Thank you.